Welcome to Wickerson Studios. I am going back to the basics once again. I think I've complicated things enough with the ghPython node in Revit 2021. But you will notice that I've opened a Grasshopper working process here within Rhino. And Rhino inside can tuck that into Revit. You can tell by these extra parameters, Revit primitives, and you can also tell by the Revit ribbon tool, which is on the top here. We're going to stay to something very, very simple. We're going to walk us into the beginning of this text, and we're going to slowly get into RhinoScript syntax functions, and we will then take that to Rhino common namespaces like I've always promised. But let's start pretty simply, going over to our math and grab ourselves a Python node and take a look at that. Obviously, if you haven't done this before, this will be 101, basically the first exercise of thinking about that ghPython component. You have inputs, which you can add to and you can subtract, and you have outputs that you can add to and subtract. And you actually have, very comparable to actually working within Rhino, going in and actually jumping into, I believe, the tools and going right into Python script editors, and jump in there and pull up the script that you might want to work directly in. And you'll find some really interesting little scripts there that I've played around with through other things. But we're not going to work directly in that. We're actually going to work directly in double-clicking this node and play around with geometries using this script. So what I'm going to do is tuck this little thing down in here, Python, and see what we could actually create. And we're not going to actually use any RhinoScript functions, too much of them. And you'll see this whole setup that pops up in the editor. And you won't need any of this initial stuff, which tells you what the inputs are, X and Y. But because we're going to be changing those, I'm just going to delete all that. It's been commented out. We're going to start by importing RhinoScript syntax as RS. And even though I won't be using that, it won't even be necessary at this point. I want to take a look at the node and go into params and consider what is the output, what's happening in out, how do I get data to actually come to there. And we'll start with something very basic, which everybody does with programming. And we'll have an output on here as well for A. And we're going to do some really basic stuff. And I'll show a few examples, and then we'll try and take this into something a little more interesting. Let's start by just going in and sending something the output with the print function. And we can throw that into quotes. And IronPython is like a 2.7 version or something like that. So you just type in, hello. Hello, Michael Wickerson. Throw that into quotes. And you can run that script, test it, and it'll stay open. And what you have is that's running, and your output is right there. And you've actually made your first little script, and you can test your script. And not only is it coming up there, it's actually coming up here now in the bottom. So you can see what's run here, and that'll be run to the output of that node. To get data at A is a little different. There'll be null here because there's nothing going into it. But let's just begin with that. And what else could we type in here? Well, we could start setting variables. We actually can get rid of these by deleting these, and you'll see it becomes a tag and there's nothing there. But if we add to, you're going to have X and Y. And what you'll want to do is if you're hard coding these, we won't even actually input a number slider here, because the main thing you want to play with in Grasshopper are number slider params, all the inputs all the way through to the panel tools. So you get the number sliders here that you can bring in. And you can play around with those after. I'm just going to bring a couple in case I do want to play around with those. But it's not important for what I'm doing right now. I'll go down to line 5. And I will simply type in things like x, set x equal to, let's say 4. So we're hard coding this. And let's set y equal to 6. And then let's generate something for a and say a is going to equal, let's say, x. Let's just do x plus y. So a pretty simple function, and we can run that. And if we do that, there you go. You've got your x and y hard-coded, and here they are. Now what you might want to do is realize that it becomes a little more important as you get into here. I'm not going to be generating geometries quite yet, but let's go in and say, maybe we do want these to be number sliders that pop in here. And at that point, right-click and change this to something like num1. Go down to your type hints and change that to floats, because that's actually what it is. It's a float that's coming in between 0 and 1. So we've got that one generating there. And then let's take this one, and you'll have to change the name again. We'll change this to num2, and we'll set that type hint to something like because I've got extended screens, I have to kind of move it over here. Let's set that to float. And now let's go in and write our script. And what's nice is you can leave what you had, and you can just hashtag it out. So it's become a comment. So that's what we were running before. And now let's go in here and let's change x to num1, and we'll add that to num2. And now you can see running the script that there we go. We've got this digit adding to that one, and you can see that's updating the panel tool. And you're starting to use this. And what I want you to realize is that it's not the geometry, the visualization geometry that you're looking at over the Rhino window. You're getting more and more back end in a sense of generating, say, something like numbers. And in generating numbers, that can drive the geometries later on. So don't think of a sphere. Don't think of a sphere as a circle. Don't think of it as a radius, but think of it as a number informing the radius. So the logical geometries you're playing with actually drive it a little more in your mind as opposed to what's being visualized in the final outcome or in the CAD window of what you bake in Rhino. So we can take a look at this, and let's just generate some scripts that are a little more exciting. So we've got num plus num2. Let's add a couple other outputs, b, and we'll multiply that by, let's say, we'll even put another variable in. We'll put a variable x. We'll add another variable, which is a new x, and I'll add that right here by adding that. And there's x. And I'm going to set that also to a type int. I'm going to set that to a type int float. And then I can bring in another number slider, and this one I'm just going to set to 1.00. So I've got a nice number slider that will do something. And that will be x times num1. And let's divide that by num2. And then let's make c x equals to num1 divided by x times num2. And you'll get better and better at this. But there's basically the script I'm going to have in Rhino. And I'm going to test it. It's going to have, it's working, but basically I don't have the B and C coming out yet. So let's just add those two. You don't have to have a type hit on outputs. It doesn't matter. It knows what it is. So there's no chance of right-clicking these and setting their outputs. I'm going to hold down Shift. I'm going to bring it in there. And there's B and there's C. Now what I have is a very simple script that even though you could generate these in other ways from nodes, that's all I want to do with Rhino with Python node right now. And we have a simple script that's running. It's generating 3 different numbers. I'm looking at them. And what I'll want to do now is start driving geometries from them. So what we're going to begin as the absolute beginner in here is we are not going to get into Rhino script syntax functions yet, like adding circle, adding line, adding things like that. We'll slowly advance to that. But I want you to figure out this node, play with this to drive some numbers, and then use that data to drive your geometries. So you're going to find this is pretty basic, but I think this is where things get playful. So go back into your skills in Grasshopper, pull in your radius 1, hold down Shift 2, and hold down 3. You could have done that, or you could have hit Control Shift and pull out all these and jam them in there. But since I'm using them down here, I'll just leave them. There are my circles generated, and there should be 3 right here, 1, 2, 3. And those are absolutely interchangeable. And we have this very interesting parametric model that because we're dealing with division, this thing can grow very quickly. And it can actually default out if this was to hit 0 because we can't divide by 0. So we'll keep going with that and see what we can do with this circle. So I'm going to see what I did with it. What I ended up doing was I thought, well, it would be interesting to possibly, what I'll do is I will grab this panel because I'm not looking at it. I'll grab a second one here and I'll copy that. And actually what I want is I want A into the radius and I want B by Shift into the radius. And then I want A into the radius and I want C into the radius. So, and I skipped A, so I'm going to plug that in and I'm going to hold down Shift and I'll get C in there. So that's a nice technique. They've got 2 circles and 2 circles. And what I'm going to do is just play around with those a little bit so they're actually fairly playful. And I can put this on that I'm actually only seeing my geometries as I select them. And one thing I like to do here is also go into my files, ensure that I'm actually in shaded because I'm going to be doing surfaces. I'm going to go into File and go into Preferences. And I'm just going to bring this back to a color that I actually very much enjoy selecting, blue, maybe a deep blue like right there. And I think that'll work pretty well. So I can see what I want to select 2 circles, and then I have over here 2 circles as well, but they seem to fall very close to one another. Oh no, one here and one here. So you've got those 2 and you've got these 2, and they share in A, the bigger circle. So let's just jump into that. And what could we do with this? Well, what I would do is I have two circles here and two circles here. One tool I really like using because I understand it well is dispatching. Just knocking it, basically bring it in as a list here, and then always flatten that list because you're looking at data. If I was to take this or another panel tool, as you look at what you're looking at, this list, you can see that it's actually coming out as two items in one branch. If I take this list and I flatten it, this list A is going to come out as one, and B is going to come out as another one. So I could actually separate that, which is something I wanted to do. But I'll just pull that back in as to what it was before it was flattened, and after it's flattened, this will actually separate it into two. If I don't do that, flatten, you'll find that, actually, what am I talking about? It's already been flattened. It should be working the same. I probably don't even need to. But I do get into the habit of flattening my lists all the time, so maybe I'll just stay with it. It's not really necessary because it actually was flattened. They were on separate branches. So I'm just going to basically flatten those, even though it's kind of unnecessary. And usually when I'm doing scripts, I'm just playing around and seeing what I can do. What I'm going to do with those circles is make a surface, and this will slow down my script, and you'll see the profiler come about. That I'll take that one, I'll grab that circle, and I'll grab this circle, and I always work from kind of data into curves, into surfaces, and then you can see the script starting to generate a little slower. I'm going to do the same thing with this one and pull it into these two. So I have one surface. If I take this, one surface, two surfaces, three surfaces, four surfaces. And even though a couple share in the same things, I'm going to show you what I'm going to actually play with. What I want to do is I want to grab a Boolean solid difference, and I want to take that one away from this one, and I want to end up with this geometry, and then I want to end up with this geometry as well. And I'll slowly bring this into extrusion, keeping in mind this is informed by data. So I have this bigger ring and I have this littler ring. And then what I'll end up doing, and I'm just going to take a look at what I was doing because I kind of forget it sometimes. I'm just going to grab a quick little scale. And I like scales with ranges, so I'm going to go for a transformation to trying to lift those things up prior to any extrusion. And this is not always the order you want to go in. But let's go into surfaces and grab ourselves a little freeform extrusion. Actually, I'm going to go in and I'm going to grab my scale. And I'm going to grab two scales. And I will basically take my geometries as my base geometry here. I'll take this geometry as here. I will throw them into a range of what you'll see is a grabbable range tool, which I do quite often. I'm going to pull that in as a factor, and it's going to kind of funk out on me here for a little bit because it's got a zero domain. It doesn't like running that. I will create a domain in my maths right here, and I will set my domain to very low number slide 0.01, so I don't go below 0. And I will take that up to some count that I might want to do, let's say 12. It's just going to be a little outrageously big. But you can see the scales that are happening. All of a sudden, I just blew that thing up, and I blew this one up. So I've got these strange patterns that are happening here because of this. I think I probably could take this edit and bring it down to something more reasonable, like 10. And I probably will not have as an integer. I'll put it in as a float. And now when I see my scales, I can play around a little bit like this and have these multiple items. Now right now I have a bunch of steps going into that. And what I really want is a very low step count. So I'm going to grab an integer step count of 3. I'm going to plug that into my steps. And now I know I have 3 circles and I have 3, closed scaled items, which can be nice. And what I'm going to do now is I'm just going to keep playing with it. I'm going to do my extrusion, and I'm going to do my extrusion through a Z vector. And it's nothing fancy here. I'm not generating anything. I use that same range to go into that vector, and now I'm going to grab my surface extrusion and pop on one extrusion there. And there's easier ways to kind of script this and make it shorter and more concise. But what I want you to get in the habit of doing is you're grabbing that base script and that base script, and you are moving them in a direction over here and over here. So you get these other forms. You get this middle 3 here. You can start to see how they're generated. You can see these ones are different. We will then do a interesting, we'll use that, which works on flat surfaces as well as working on solids. So we can jump in here as a solid difference. As soon as I get it, solid difference, I'll grab this breadth and this one, and I'll minus that other one. It's going to take a little bit to load. We're at 748 milliseconds on what's going on there. And now I will probably do a union of these to bring them together. And some people don't do it this way, but I kind of think about it this way. I'm bringing my solid union. And we're starting to get down to some interesting objects. If I was to select exactly what I'm seeing here, it's that middle one, not everything else. I've narrowed this whole script down to this. And I will take that as a length item into my sets. And I would do a little bit of math on this, and I will throw that through a range again. But one thing you're going to want to do with counts is you're going to want to take the steps as that length count, but you're going to want to set your equation expression to x minus 1, because you want one less on the count. And now you have a domain that you can play with, and what I'm going to do is throw that domain through the exact same domain that I had here. So this little 3 that I was playing into here as a step count is actually going to become my, let me just see for a second. I'm going to take, I think it was the 3. Yep. I'm going to keep my count very low because the script gets pretty slow if you're not doing this. So I'm just going to grab that 3 and bring it in here as my domain. And I've got a range that I'm going to play with. I'm going to bring that up again through a z vector. And then I'm going to take my geometry and do a move. So transformation and moving it up in that direction. So all that motion is playing through here. And what's my initial geometry of what I wanted to play with? It will be that union, that union. And now I've got an object that I can take to bake, and I'm going to shrink this all and say there's my script. But what's happened here is I've written a very simple number script in Python, but you start desiring to know how to add a circle. You want to know how to dispatch things, and you can start using some conditionals and logics to do that. You can put some surfaces on things. You can do all these transformations, but all of these nodes are scripted and coded kind of plugins, miniature plugins that you can write and run on common. So you'll find out where you want to go. Keep things dead simple. Keep the geometry simple. Play through it. And when you end up here, you can take the bake, and let's just, before I take the bake, let's see how many geometries I have here. I have 2 closed breadths at this point, and that will change because of how things come together as the lines. So it's not always 2 closed breadths. But let's just go in here and grab a bake. Let's keep them separate and throw them in. And there we go. We have this object, which I can take over here. And I didn't group it, but there should be 2 breadths that are actually baked here. And I probably select edit this one. Actually, I don't want to select edit that one. I want to. It's a pretty interesting form. Like, it's not so interesting on the top, but it's definitely interesting on the bottom. So my 2 breadths have actually come in as 2 closed breadths. So let's just grab that little one, tuck it off to the side for a second. And at that point, you can do any of your scaling, your non-uniform scaling, and things like that to change it, because now you're working in CAD. But let's go back and let's just go back into it and go back to where we were with the number sliders and start to play off of this. So we want to make everything visible, and then we're going to want to slide this around. It's a slow script, so you got to wait a few milliseconds. So you're getting into here, and I just wanted to play with it, that maybe through a little bit of play here, this factor is going to really change it. There we go. So what we have here as we wait, and I moved it a little farther than I wanted to, because you're actually playing in the maths, it's activating this, and it's controlling the geometries. And this is a nice tool to kind of zoom out and see everything. Let's just go down here at the end and see. Now look at that, we have 4 different breadths. So if we bake this one because they didn't connect, we actually have 4 geometries where the script was only producing 2 closed breadths before. So I'm going to take this to bake, and I don't have my different layers on here. I could do it by layer. I think I'll just throw it in and see what ended up happening. This one will move this way, and now you've got your separate breadths, and that's what I was hoping to get on the last one. 1, 2, 3, and there we go. And it's interesting that those actually, some of them found a way to union together, and other ones didn't. So if I go back, you know, you've got this whole form that I could have grouped when I baked it in, and if you didn't, you could always go here and then group afterwards. Yeah, grouping in here, select the groups, and there we go. And now you've got something you can grab and just move off to the side. So you've got a pretty interesting script that, once again, you can do things later. Your geometries are not tough, but your main practice here, as you go into this, and I guess I'm getting to like, what, 10 minutes or something like that, you've written a script that you can anticipate how you can take this dozen or 2 dozen node script and start to tuck it into this Python node. And up until now, you might have been working solely in Grasshopper and taking all of these and using the scroll tool to basically come in here and try and cluster this whole thing and pull it into a node like that. And of course, it's like, what did you just do? And you made a little node that's kind of like a Python node, but if you've gotten tired of doing that, pulling these items up here and trying to coordinate them, and you actually want to have a much more Python-oriented scripts that you use again and again, then you definitely don't want to go into that. You want to, it's just going to take me a second to back out of that. We're going to slowly, as we get through this book, bring more and more Rhino script syntax functions and hopefully Rhino common namespaces in so we can figure this out and tuck these into scripts that you're literally just looking at the Python node with its inputs that have their item access, list access, tree access, and then they're outputting not only your out script as how it's running down here, but also you're running out your outputs into certain geometries. So this one you would really rather have that being outputted in into a single way into something like the params going into the brep, because that's really what you're producing. So instead of going through all this, you could write into your Python scripts. So you end up with all that condensed that you're ending up with this final one. So not too exciting, but I want to go back to the basics, and we've taken a look at the ghPython node pretty specifically, and we'll go in and we'll talk about the Rhino script editor. We'll deal with data access, which we covered a little bit here, and then we're going to play around with a little bit of the arithmetic operators and variables that are accessible to you through basic Python. So I hope you find this series helpful for your intermediate people and people that are even beginner at this for a while. This is going to seem very trivial and new, but once again, I'm trying to get students in a sculptural major to get onto the computer and realize the possibilities of moving this even farther and farther into programs like Revit. You're going to be able to activate things and start dealing. Hopefully, the pinnacle would be working in generative kind of design and optimizing your formulas and figuring things out. But right now, we're starting with such basic scripts that print is the only function we're really pulling in at this point. And of course, there are these operators and arithmetic operators we're already starting to play with. So you fly very fast in this book, and things get complicated really quick. But a little bit of your creativity is going to go a long way when it comes to research and developing what we're doing with the ghPython node. Michael Wickerson, Wickerson Studios, and thank you.